Hello and welcome to Smooth English. In this video, we are going to tell the story of Albert Einstein. Today, we'll explore his life, his groundbreaking work, and the big ideas that changed how we see our universe. Let's dive in. Curious child. Albert Einstein was born on March 14, 1879, in Ulm, a city in Germany. His family lived in a small house near the river. His father, Hermann, sold electrical equipment. His mother, Pauline, played the piano and loved music. From a young age, Albert showed deep curiosity. When he was 5, his father gave him a compass. Albert stared at the little needle that always pointed north. He wondered why the invisible force made the needle move. This moment sparked his lifelong love of science. At home, Albert had a sister named Maria, called Maya. The two children played together and shared books. Their mother read them fairy tales and stories about nature. These stories filled Albert's imagination with questions about the world. When Albert was 6, he started school in Munich. He learned reading, writing, and arithmetic. First, he did well. He loved math problems and puzzles. But he did not like strict rules or memorizing facts. By the age of 8, Albert felt bored in class. He thought some lessons were too easy or too dull. He often asked his teachers why things worked the way they did. His questions sometimes annoyed them. In Germany at that time, students were expected to follow orders without asking too many questions. Outside of school, Albert enjoyed exploring. He liked to watch trains and study their engines. He often took long walks with his family. Nature became his outdoor classroom. He collected sticks, stones, and plants to examine at home. Music was also important in Albert's life. His mother taught him to play the violin when he was 6. At first, he did not like practice. Yet over time, he grew to love the violin's sound. Music gave him comfort and a way to think deeply. In 1885, Albert moved with his family to Milan, Italy, because his father's business needed help. The change was hard. Albert missed his friends and school in Munich. But Italy's bright sun and new places also excited him. He spent hours reading books on science and philosophy. By the end of chapter 1, Albert is a curious, thoughtful boy. He asks questions, explores his world, and finds beauty in music. These early years show the start of a mind that would one day change science forever. Chapter 2, School Years and Big Questions. Albert's formal schooling began at the Luitpold Gymnasium in Munich. He enjoyed numbers and logical puzzles, but he bristled at strict rules. Teachers expected students to memorize facts without asking why. Albert often fell silent in class, lost in his own thoughts. By age 14, he doubted whether this rigid style would ever satisfy his curiosity. When his father's business struggles forced the family to move to Milan in 1894, Albert left school early. He felt uprooted and anxious without his friends or familiar classrooms. Yet Milan brought new excitement. He spent long afternoons in the public library, reading books on geometry, algebra, and physics. These readings fueled his early ideas about space and time. Albert's self-study routine in Milan looked like this. Morning, work through geometry exercises on paper. Afternoon, read science texts. He especially loved Maxwell's treatise on electromagnetism. Evening, play violin and jot down questions in a small notebook. He managed the schedule alongside helping his father with business letters in German and French. His notebooks filled with sketches of gears, arrows, and hand-drawn diagrams of light waves. In 1895, at age 16, Albert decided to resume formal education in Switzerland. He traveled alone to Aarau and enrolled at the cantonal school there. Aarau's teachers encouraged students to debate ideas instead of just memorizing them. In his new classroom, Albert could raise his hand freely. He felt a spark of hope. Here was a place where asking why was welcome. Living with the Bleuler family in Aarau gave Albert a comfortable study space. His daily life included breakfast conversations about art and literature, morning classes in physics, math, and French, afternoon free time for reading Newton's Principia or writing short essays. evening violin lessons with local musicians. His classmates, many older than him, admired his sharp mind. They nicknamed him Der Professor, because he often explained difficult concepts to others. One winter afternoon, Albert walked home pondering light. He imagined chasing a beam of light at full speed. If he could travel beside it, would the light stay still? This thought experiment became the seed of his later work on relativity. He wrote furiously in his notebook, drawing rays and clocks, unaware that these sketches would reshape physics. By 1896, Albert was ready for the Swiss Federal Polytechnic in Zurich. To pass the entrance exam, he wrote an essay on heat flow in solids, a topic he chose himself. He spent weeks practicing past papers in mathematics and physics. His self-confidence grew as he solved each problem without help. On his exam day, Albert answered every question correctly in math and science but did poorly in language and history. He failed the general exam but passed the special physics and math section with top marks. The Polytechnic granted him a place after a year of preparatory classes back in Aarau. He returned home proud, eager for the vibrant academic life that awaited him in Zurich. Chapter 4. A Patent Clerk in Bern. In 1902, at age 23, Albert Einstein began work at the Swiss Patent Office in Bern. Every morning, he rode a tram to the office. His job was to examine patent applications for new inventions. He looked at technical drawings and tested ideas for machines and electrical devices. Although the work was not very exciting, it gave Albert a steady routine. He could think about physics problems while he reviewed papers. He learned to write clearly and explain ideas in simple language, skills that helped him later as a scientist. After work, Albert returned to his small apartment in Bern. He shared the flat with friends or lived alone, depending on the year. Evenings often meant playing his violin or taking long walks along the Aare River. His friend Michel Besso joined him sometimes, and the two discussed questions about space, time, and light. In his spare time, Albert wrote scientific papers. In 1905, his miracle year, he published 4 major articles in the journal Annalen der Physik. Each paper addressed a different problem. Photoelectric effect. He showed that light can behave like tiny particles called photons. When photons hit metal, they can knock out electrons. Brownian motion. He explained why tiny pollen grains move randomly in water. Their motion comes from invisible atoms bumping into them. Special relativity. He proposed that the laws of physics are the same for all observers moving at constant speed. He showed that measurements of time and space change with speed. Mass-energy equivalence. He derived the famous equation, which means energy, E, and mass, m, are 2 forms of the same thing, linked by the speed of light, c. By the end of 1905, scientists around the world began to notice his work. His clear writing and bold ideas made him famous almost overnight. From a quiet patent clerk, Albert became a leading voice in physics. Chapter 5. From Patent Clerk to Professor. In 1908, Albert Einstein's 4 papers from 1905 had made him a rising star in physics. The Swiss Patent Office could no longer contain his energy for teaching and research. That year, he accepted an offer to lecture at the University of Zurich and left the patent office behind. As a lecturer, Einstein stood before small groups of students. He explained complex ideas like how time can stretch for a moving clock in clear, simple language. He also published more papers on thermodynamics and statistical mechanics, deepening his understanding of heat and motion. In 1911, Albert moved to the German University in Prague to become a full professor. There, he enjoyed a larger salary and more freedom to explore gravity. He spent long hours with chalk and blackboard, wrestling with how mass could warp space and time around it. By 1912, Einstein returned to Switzerland as a professor at the Zurich Polytechnic. He teamed up with his old friend Marcel Grossmann, a mathematician who introduced him to the powerful language of tensors. Together, they laid the mathematical groundwork for a new theory of gravity. In November 1915, after nearly a decade of work, Einstein presented his field equations of general relativity to the Prussian Academy of Sciences in Berlin. His equations showed that massive objects like the sun bend the fabric of space and time, causing planets to follow curved paths. This bold idea transformed how scientists view the universe. With the publication of The Foundation of the General Theory of Relativity in 1916, Albert Einstein firmly established himself as one of history's greatest thinkers. He had journeyed from a quiet patent clerk to a celebrated professor whose ideas would shape modern physics and inspire generations to come. Chapter 6. War and a New Light. When World War I began in 1914, Albert Einstein was a professor in Berlin at the Prussian Academy of Sciences. He lived in a quiet neighborhood and walked each morning through tree-lined streets to his office. Though he was German by citizenship, Einstein did not believe in war. He missed his family in Switzerland but felt safe in Berlin's calm, scholarly world. Across Europe, many scientists signed letters supporting their country's armies. Einstein signed a petition calling for peace instead. He wrote essays asking writers, artists, and scientists to work for a world without guns. His pacifist voice stood out among the noise of fighting. Even as cannons fired on distant battlefields, Einstein's mind returned to gravity and space. In 1916, he published The Full Theory of General Relativity. The paper explained how massive objects, like stars and planets, bend the fabric of space and time. He knew only a few physicists would read it. He hoped, though, that one day the world would understand his bold idea. Meanwhile, life in Berlin grew harder. Food was scarce. Paper for books and newspapers was in short supply. Yet Einstein continued to teach small classes. He helped students learn to solve the complex equations of relativity. His lectures gave young minds a chance to dream of a peaceful future shaped by ideas, not armies. In May 1919, a team of British astronomers led by Sir Arthur Eddington traveled to two remote spots, Principe Island off Africa and Sobral in Brazil, to watch a total solar eclipse. They measured the positions of stars near the sun. Einstein's theory said that starlight would bend around the sun by exactly 1.75 seconds of arc. When the data came back, the measurements matched his prediction almost perfectly. On November 7, 1919, newspapers around the world announced the result. General relativity was confirmed. Headlines shouted that Einstein triumphs and called him a scientific hero. Albert was both surprised and pleased. He had spent years working quietly at his desk. Now his name was on every newspaper. Suddenly, Einstein was invited everywhere. He gave interviews to reporters. He received letters from schoolchildren in America, Japan, and Australia. They drew him as a kindly old man with wild hair. At home, he laughed at their pictures and answered as many letters as he could. He felt glad that science could unite people, even after a terrible war. By the end of Chapter 6, Albert Einstein had seen his boldest idea proven true. From Berlin's quiet streets to the tropical islands of an eclipse expedition, his theory had connected science and the wider world. He was no longer just a professor or a former patent clerk. He was a symbol of hope, proof that peaceful ideas, like gravity itself, could bring people together. Chapter 7. Across the Ocean, Einstein's American Adventure. Albert Einstein stepped onto the deck of the SS Cap Polonio in late March 1921, the salty wind tugging at his unkempt hair. He held a small suitcase in one hand and a sheaf of lecture notes in the other. Beside him stood his cousin and close companion, Elsa, who gently placed her hand on his shoulder. As the ship pulled away from Bremen's docks, he felt a mixture of excitement and longing, for the calm of Berlin, for his work at the academy, and for the unknown world ahead. When the Cap Polonio arrived in New York Harbor, the Statue of Liberty rose like a promise of new possibilities. Reporters crowded the quay, cameras clicking non-stop. Einstein, tall and lean, waved awkwardly but warmly. In his heart, he carried hopes that science might bridge nations still healing from war's wounds. Over the next 2 months, he toured universities from Princeton to Chicago. In packed lecture halls, he sketched diagrams of curved spacetime on chalkboards so large they needed two assistants to move them. His simple English, mixed with breaks of German, made students lean in, eager to grasp ideas that once existed only in his private notebook. After each talk, his audience applauded not just the theory, but the gentle man who spoke of peace and understanding as fervently as he spoke of light and gravity. Evenings brought dinners with American physicists, community leaders, and school children. He visited public schools in Harlem, where children greeted him with handmade signs reading, "Welcome, Mr. Relativity." Their bright faces reminded him why he traveled so far. To sow seeds of curiosity and cooperation. In letters he later wrote home, Einstein described tasting pumpkin pie for the first time and marveling at the endless fields of Midwest corn. By May 1921, when he received an honorary doctorate from Princeton University, Einstein understood that fame had become a tool. He used it to speak out against lingering nationalism. In speeches and newspaper interviews, he urged Americans and Europeans alike to value knowledge over conquest, dialogue over division. As he boarded the Cap Polonio for his return voyage, he carried with him new friendships, fresh ideas, and a conviction that the world could be reshaped by peaceful exploration. Chapter 8. Einstein's Quest for a Unified Field Theory. After the success of general relativity in 1919, Einstein believed that nature's forces might share a single, elegant source. He turned from gravity alone to a grander aim, to find a unified field theory that would join gravity with electromagnetism. In his study in Princeton and later at the Institute for Advanced Study, he filled dozens of large notebooks with new equations, hoping to reveal nature's hidden unity. Einstein imagined that electric and magnetic fields, the forces behind light and electricity, were different faces of the same cosmic fabric as gravity. He revisited the mathematics of Hermann Weyl, Theodore Kaluza, and others who had already suggested ways to merge forces. In 1921, Kaluza's idea of a fifth dimension lit a spark in Einstein's mind. If space had more than three dimensions, perhaps gravity and electromagnetism would be two expressions of one geometry. Throughout the 1920s and 1930s, Einstein worked almost alone on this puzzle. He exchanged letters with fellow physicists like Erwin Schrödinger and Wolfgang Pauli, seeking clues and advice. Yet most of his peers focused on the strange new world of quantum mechanics. Einstein respected quantum theory's success but disliked its randomness. He insisted that God does not play dice, and he hoped his unified approach would restore determinism to physics. Einstein's notebooks show both soaring confidence and moments of doubt. Some days, he sketched elegant symbols connecting curvature of space to electromagnetic fields. Other days, he crossed out pages, sensing the path was wrong. His wife, Elsa, brought him tea and quiet company when he grew frustrated. His colleagues teased him gently for chasing what seemed an impossible dream. By the 1940s, Einstein had tried many versions of his theory, sometimes adding new mathematical terms, sometimes proposing subtle changes to the way space itself might twist or stretch. Yet no model matched all observations. He longed for experimental evidence, but the new particles and forces discovered after World War II lay outside his classical framework. Quantum physicists pressed ahead, while Einstein's unification work remained on the margins. Even as he aged, Einstein rose early each morning to write new pages. His handwriting became shakier, but his determination never wavered. Late at night, a single lamp lit his desk while he wrote to colleagues about alternative field equations. He hoped that some young physicist, building on his notes, would finally complete the theory. When Albert Einstein died in 1955, his unified field notebooks contained more failures than triumphs. Yet his quest left a lasting legacy. He showed that a single mind could dream of connecting the universe's forces in one grand design. Future generations of scientists working on quantum field theory and string theory would owe their first steps to Einstein's bold vision. Chapter 9. Twilight at Princeton, a Refuge for the Human Spirit. When Albert Einstein arrived at the Institute for Advanced Study in Princeton in 1933, he carried more than a suitcase. He carried the urgency of a world on the brink. Nazi edicts had stripped him of his German citizenship and his library at the Berlin Academy. Yet on Nassau Street, he found a new home where ideas could flourish without fear. Each morning, he walked the leafy campus paths in his rumpled coat, greeting colleagues with a gentle nod. He resumed his seminars on relativity and unified field theory, though fewer students attended. Many were drawn to the emerging quantum revolution. Still, Einstein valued the smaller circle. Late-night discussions over tea, debates about physics mingling with worries about the war raging in Europe. In 1939, alarmed by reports of atomic research in Germany, Einstein and physicist Leo Szilard penned a letter to President Roosevelt. They warned that nuclear chain reactions could lead to powerful bombs. Though Einstein did not work on the Manhattan Project, his signature helped set in motion America's atomic program. He watched the explosion at Trinity in 1945 from afar, torn between relief that the Nazis had not prevailed and dread over humanity's new destructive power. Away from equations, Einstein found solace in music and friendship. He played violin for small gatherings in his study, inviting fellow émigrés to share Yiddish songs. He supported Jewish refugees, fundraising for Princeton's Hebrew University. His home became a haven of warmth, Elsa's baking, spirited conversation, and a constant stream of letters from admirers and challengers alike. As the world rebuilt itself after 1945, Einstein felt both hope and melancholy. He expanded his peace activism, joining calls for global disarmament and a world government to prevent future wars. His public essays urged nations to relinquish weapons and embrace cooperation, echoing the pacifism he had voiced during World War I. By the late 1940s, frailty crept into his once steady frame. Yet he rose before dawn to scribble new field equations by lamplight. Even as his body slowed, his mind remained restless, seeking the simple, unifying thread he believed wove the cosmos together. Chapter 10. The Man Who Changed Our View of the Universe. In the spring of 1955, Albert Einstein's health began to wane. He declined surgery for an abdominal aneurysm, preferring to face death on his own terms. As he lay in his Princeton home, friends and former students kept vigil, reading him poetry and the latest physics journals. He smiled at their recitations, eyes bright with curiosity even as his body weakened. On April 17, 1955, he confided to his secretary that he wished to go when I want. It is tasteless to prolong life artificially. 8 days later, he slipped away quietly in the early morning. News of his passing spread swiftly. Newspaper headlines mourned "the world's conscience" and "the last wizard of physics." Yet Einstein had insisted on no state funeral. His remains were cremated, and his ashes scattered at an unknown location, freeing him, as he once freed physics, from earthly constraints. In death, as in life, Einstein inspired wonder. Scientists later examined his preserved brain, searching for clues to his genius. Philosophers and poets invoked his humility, his refusal to accept mystery without question. Children continued to sketch him with wild hair and twinkling eyes. Letter-writing campaigns to his widow chronicled their affection for the gentle scientist who spoke of peace as passionately as he spoke of light. Einstein's published papers and private letters endure as a testament to a mind unafraid of failure. His unified field notebooks, once dismissed, became seeds for modern string theory and efforts to reconcile gravity with quantum mechanics. His public stands on war, civil rights, and international cooperation echo in today's debates on science and society. Decades later, visitors still trace his footsteps at Princeton, stand beneath the oak where he paused to think, and glimpse his violin case in the Institute's archives. His legacy remains a living bridge between imagination and reality, reminding us that one person's curiosity can reshape our understanding of the universe. Albert Einstein's story shows how curiosity and perseverance can change the world. From a child enchanted by a simple compass to a thinker who reimagined space and time, his journey reminds us that asking why is the first step to discovery. His life also teaches us that even great minds face setbacks. Einstein's unfinished quest for a unified field theory proves that failure can fuel future breakthroughs and inspire generations of scientists. As you follow your own questions, big or small, remember that every idea has the power to spark a new adventure in learning. If you enjoyed this video, click the like button. Subscribe to our channel for more simple stories of great thinkers. Hit the bell icon so you never miss an episode. Leave a comment below and tell us, what question will you explore next?